James Webb Telescope announced a terrifying new discovery on Pluto. Recent findings and ongoing missions have drastically changed our understanding of Pluto, the first planet outside of our solar system. Scientists studying Pluto uncovered astounding features that had never been identified previously in our solar system, even though it was once assumed to be an icy dwarf planet with very little activity. It's delightful to know that our understanding of the world at large has vastly improved. We are grateful for the recent increase in space observations. Scientists are making incredible progress with the ever-outstanding James Webb Space Telescope, and what they have discovered about Pluto is just as remarkable. Pluto, the largest sized known dwarf planet in the solar system, was previously thought to be the ninth and farthest planet from the Sun. The mysterious planet is in the Kuiper Belt, a region beyond Neptune's orbit that is swarming with 1 trillion or more comets and countless thousands of ice planets, each diameter wider than 62 miles. Pluto was demoted to a dwarf planet in 2006, ending its status as a planet. This reclassification provoked discussion and disagreement among scientists and the general public. Pluto is so far from Earth that very little was known about the dwarf planet's size or surface conditions until 2015, when NASA's New Horizons space probe performed a close flyby of Pluto. NASA's New Horizons mission is the only project mainly aimed at examining Pluto, its moons, and any potential extrasolar planets in the Kuiper Belt. According to New Horizons, Pluto has a diameter of 1,473 miles, which is less than 1/5 the diameter of Earth and only about 2/3 the width of the Earth's moon. If Earth is the size of a nickel, then Pluto is a popcorn kernel. Pluto has an orbit that is more than 49 times as elliptical as Earth's. Pluto's distance from the Sun varies significantly due to the dwarf planet's highly eccentric orbit, which is far from circular. For 20 years of Pluto's 248-year orbit, the dwarf planet approaches the Sun closer than Neptune, providing scientists with a once-in-a-lifetime opportunity to study this little frigid remote world. After 20 years as the 8th planet, Pluto surpassed Neptune's orbit in 1999 to become the planet farthest from the Sun, a position it held until it was declassified to the status of a dwarf planet. Pluto has one of the coldest surfaces in the solar system. Temperatures can drop from -375 to -400 degrees Fahrenheit here. Hubble Space Telescope images of Pluto revealed that the dwarf planet had gotten redder over time, most likely due to seasonal fluctuations. NASA's New Horizons mission is the first to closely observe Pluto, its moons, and additional planets in the Kuiper Belt. The mission launched in January 2006 and successfully achieved its closest approach to Pluto on July 14, 2015. In October 2021, New Horizons sent back the first close-up images of Pluto and its moons, making history. Because of our inadequate understanding of the Pluto system, the New Horizons mission faced extraordinary threats. According to astronomers, only 3 moons around Pluto were known to exist before the mission's launch. The discovery of Kerberos and Styx during the spacecraft's journey spurred speculations that there could be other unseen satellites orbiting the dwarf planet. Small debris or even unnoticed moon encounters might have seriously injured the spacecraft. The space probe was provided with equipment by the New Horizons design team, though to keep it secure while in transit. During the meeting, it was discovered that Pluto was a tremendously diverse planet, complete with vast plains of strange nitrogen ice and towering water ice mountains. Pluto features a large area with a heart-shaped surface, unofficially known as the Tombaugh Regio. On the left side of the Tombaugh Regio is the Sputnik Planitia, which resembles an ice cream cone and is covered in carbon monoxide ice. More variations in the chemical composition of the surface components have been discovered within Pluto's heart. The lack of craters from meteorite impacts on the surface of the Sputnik Planitia indicates that the region is relatively young, less than 100 million years old on a geological timescale. According to experts, Pluto's trajectory changed due to the intense concentration of ice in the Sputnik Planitia zone, which New Horizons estimated to be roughly 6 miles thick. Looking at less likely possibilities, the scientists determined that a subsurface ocean is the best fit for the findings, although thicker ice covering or vibrations in the rock could be to blame. Scientists believe Pluto could host life if it had a liquid ocean and enough energy. The James Webb Space Telescope can help researchers in their search for life on Pluto, though. To complete this process, scientists will send a probe to Pluto, which might send samples back to Earth for analysis. These probes have discovered about 5,000 exoplanets, and hundreds of these exoplanets are estimated to be capable of harboring life. However, a dwarf planet like Pluto can be observed with the James Webb Space Telescope. Astrobiologists look for indications of life by analyzing the light that is reflected or absorbed by a planet's surface or atmosphere. The surface or atmosphere will indicate if life has ever existed on Pluto. A biomarker or a hint could be present in the light that passes through the atmosphere. For example, for the first half of its existence, the Earth hosted primitive single-celled life, but its biosignature was very weak because the planet's atmosphere was devoid of oxygen. A new family of algae appeared in the past 2.4 billion years. These algae produced oxygen as a byproduct of photosynthesis, which they utilized. This oxygen has no chemical bounds with any other elements. At this point, a discernible biosignature of light began to be produced by Earth's oxygen-rich atmosphere. Scientists believe that some wavelengths of light that reflect off a material's surface or pass through a gas are more likely to become trapped there. The selective trapping of specific wavelengths explains why objects have different colors. The way light reacts with a substance determines the pattern of missing light. Astronomers can use this light trapping to discover more about a planet's atmosphere or surface composition. Astronomers will be able to determine the presence of particular atmospheric gases associated with life by examining the precise color of the light that Pluto emits. It could also discover unique colors on a planet's surface since they produce very distinct light imprints. Only the James Webb Space Telescope can complete this type of analysis on light emitted by a distant planet, which explains why there has been so much excitement about it studying Pluto. The James Webb Telescope has already demonstrated its fantastic capabilities. For example, scientists were able to examine the exoplanet WASP-96b's light spectrum when the James Webb Space Telescope began conducting research activities in July 2022. The spectrum analysis confirmed that the exoplanet contained water and clouds, but owing it to its size and temperature, WASP-96b could not have supported life. The James Webb Telescope examined Jupiter too, and the results were extraordinary. This result demonstrates that the Space Telescope will have no trouble researching Pluto. NASA has made some of the demonstration photos public. The photographs also showed that the James Webb Space Telescope can focus on close objects. Even though they were not processed, the level of detail was astounding. The images show several moons, including Europa, Jupiter's cold bands, the massive Great Red Spot Storm, and even parts of its faint rings. The enormous planet, the rings, and the Great Red Spot are also visible in the most recent images. The images help scientists understand the planet's auras, winds, and thermal patterns. Did you also know that the dwarf planet orbits our solar system counterclockwise from east to west, dismissing all of the characteristics that differentiate the other 8 planets? There is a lot of information about Pluto that has yet to be uncovered. For the time being, we expect the James Webb Telescope to take close-up photos of Pluto, allowing us to have a better understanding of what lives there. And on that note, we have come to the end of this video. Do you think the James Webb Telescope will be successful once again in examining Pluto? Let us know what you think in the comments section. Do not forget to give this video a thumbs up, smash the subscribe button, and turn on that notification bell to get notified when we post a new video.